So linked list is asked in questions in interview. It is important in terms of interview, but it is not that difficult to understand. We'll solve it. Okay. First thing, what we will check what is a single linked list. Single. Then we will check what is a double linked list. Double. But it is like if you understood what is single linked list, right? Double linked list just extension. कुछ नहीं है, easy है. Then we need to understand difference between linked list and array. सब पूछते हैं linked list क्या है, array क्या है. So if we understood what is linked list, we know what is array, and I will show you how it is different in terms of memory also. Okay. So a good explanation will be given for this. Okay. Then there are some operations that are done on a linked list. Okay, like addition, we have to add a node to the linked list. Then we need to traverse पूरे लिंक लिस्ट पे चलो. So forward, reverse, anywhere traverse, we will do it. Then deleting an object or a node from a linked list. एक नोड बता देंगे, उसको डिलीट करना है, that's it. And then there is search anything. So let's start. Okay. Single linked list. So पहले तो linked list use कहाँ होता है, where we use linked list. Linked list is just like if you enter your details in any website, it's not going to maintain your data sequentially. It sometimes maintain in a random fashion. Like that, it is linked list. Because if we want to link a data, let's say int a equals to 10 and int b equals to 20. Let's say these are the age 10 years, 20 years, okay, of two customers, and I say a is the first customer to visit, b is the second customer, but I have this data separately. Now I want to link a to b. How to do that? The only way to do it in c is we need to know the somehow a should know the address of b, then only it can link. So a should have one part, that is data. Okay, that is data, and a bar, that is address, which stores the address of B. So we should have something or some that data type that somehow represents a fashion, represented in a fashion like it should have a data and a pointer to next data, right? So that's what linked list is. Let's see here what I told. So first will be the data sorted, then next this is a pointer. This stores the address of this node, then this will store the address of this node, and finally at the end this is the end node, so it will only have null to it, right? So that's how it is. Data can be anything, integer, character, or any separate structure to that matter. Then one more thing is head. We should always know where to start from, right? It's a linked list. We are linking one node to other, like this node knows the address of this knows the address of this. Finally we should know what is the starting point, so head always contain the address of the starting node. So every linked list need a head. So let's go to the definition. Single linked list contains data and address of the next node, right? हमने देख लिया. Then data can be of any type, right? It can be of any type, we don't worry about it. Then it should store the address of the next node, right? Next node का address store करके रखना है. Now every node is this structure itself. So how we create a node should have a data and a pointer that is of the same structure type, because in this pointer we want to store the address of the next node, so that pointer should be of this node type. See, so how to create the node of for a linked list? Easy. Structure, a data type, a data, and a pointer of the same node structure. Simple. Now first we have to create a head to start with the linked list. So let's create a head. So as you know, it's this structure should be maintained. There should be a data. Here I have taken int, and then there should be a pointer which should be of the same structure type, because we want to create small unit of this structure, and we want to store the address of this entire structure in this pointer. That's why this pointer has to be of this structure type. Okay. Now we see head. So how we create a head? We create a head using this malloc function. What it does, this allocates memory. So we need to create a head, that is the head should point to a memory which is of the same size that of the structure. of this structure. So we just give this command and malloc will allocate the memory, and malloc will return address. So head is also a pointer of structure type that stores the address of the starting node, right? Then we don't know what is the next element for that node. That's why we assign it to null, and we give any random data. I given it 1. Okay, so let's see. So head is this one, so this one is head. Then next one is null, as I don't know. Now somebody come and said, oh wait, I know the next node. Then we remove null and we assigned it to this. And similarly, next to it is also null. Then again say, why you are assigning null? Assign to the next node. This is the next node, but we don't know what is next. That is null. So every time the node which we will be linking should be pointing towards null. So the end node will always point towards null. Remember it. Head is the one which is pointing towards the starting node, and the end will be pointing towards the that is null. So that we called single linked list opened ended. Now there is another concept that is circular, like it should again points towards head. Leave that thing. That is like nothing more. You just point, make sure that the last node always points towards head. That's it. So let's now jump towards the coding part to see how we achieve it in the code. So remember what we have to see. We have to see addition, traverse, deletion, and search. Add, traverse, delete, search. Okay. So I have taken online C compiler. You can take any compiler you like. It's your choice. Okay. First thing, what we need to do: create a structure, struct node. Okay, fine, and we give it here int data. Then same thing as I told, a pointer of the same structure type. We give it next. Okay. So our structure is created. Now we need to create head. The first node should be pointed by the head. So what should be head? Head should always be a pointer because it is pointing. Okay, head is a pointer, and we first assign null to it. Then we say head equals to malloc size of what? Size of the struct node, because the node size of memory only we need. Every unit of this is of size this node. That's why we need the size of that node. Now the head will have a part called data. So I assign it like as 1, and then head next. We don't know, so we assign to null. So our task is complete up to it. Like we have created a node and we have assigned it to the head. So this is the starting point of your code for linked list. We run it. So what it is saying, int main. Okay, we forgot this one. Now run it. Okay, so much. We need to include one library, stdlib dot h. Now run it. See, hello world. So clear? Just joking. We are not here to print hello world. So now let's add nodes to our head. We increase our linked list size. How we do it? We create a function. Let's say add nodes. So we need the head. So it needs head. So we completely give it head, and we need data for the next node. Like whenever we have a data, we create a node, right? So this is the data, and we know what is the head. We create the node. So we need to go to, we have to create a new node. So we create a node called new, that is null for the beginning. Now if you see here, we can we can only add data to the end, not in the between. We can only add data to the end. So how we will do it? Just do while head dot next not equals to null, we say head equals to head next, right? So what we are doing, we are trying to reach this end node. So we are saying head is here, right? Head is, so head is here. Let me take this one. So head is here. Then we say okay, head becomes head towards next, head goes here. We check if next to it is null, no, then head goes here. Then next to it is null, yes it's null, we stop here. Okay, that's what we are doing. So we go till the head is towards next is null. Now we found that we have reached the end node. Now we create a new node. So new equals to malloc size of, okay, let's just copy paste this. Nothing is there, only copy pasting. New data equals to data, and new next equals to null. So every time you create, you follow the same concept, data null. Then you have to put here head next equals to new. So our new node has been added. So this is done. Now we have to write a logic to print it. What we are adding, we need to print it. So we just say void print node. So we need the head. So every operation or every function needs head because that is the starting point. So we print while we don't encounter null, while head is not equals to null. So we say printf percentage d pointing towards the next, that is head data, and head equals to head next. Then at the end we will just print null. Okay, so remove it, add node, then print list. So printing list is also same as traversing means we are traversing the linked list. Okay, so we, how we add a node, just copy this. I told you, right? It's only copy and paste, copy karo paste karo, and we give it head, and we give a data, let's say 4 4 4 5 6, and here we just print it. See here, so it is printed 1 4 5 6 null, right? So traversing is also done. So next thing is we add few more nodes, and then we write the logic to search something, then we will delete it. So 7 and 9, again we run it. See, 7 9 has been added. Now just write a code to void search search data. What we need a structure. Okay, we copy this whole thing. We need the structure and a data to be searched. So structure and date and search data, So what we need to do, simple. We need to check. If we want to search 6, it is like 1 is equals to 6, no, then go to the next node. 4 is equals to 6, no, go to the next node. 5 is equals to 6, no, go to the next node. 6 is equals to 6, yes, we found the data. So here we will say head. We have to traverse till it does it's equals to null. Then we have to check head data was equals to search data. Here we say if was equals to search data, then we say printf search data found slash n, and we keep a marker like found equals to 0. So found becomes 1 here, and we break the loop, right? So if found was equals to 0, and we say not found, simple. Okay, now we just use this function to search. Search data, let's give it as 7. Then again we search something that is not in the list. Let's give it 10. So I just done it. Okay, why it is not printing anything? Okay, head search data equals to if head equals to search data print found break found equals to 0. We are giving return here, so this statement itself is not executing. These are the mistakes. So some infinite loop is running or what? Oh, okay. We forgot to increment this one. So here in the while, we just need to say head equals to head next, right? I hope you catch this error, right? See, first data is search is found, that is 7 is found and 10 is not found. So that's how you search it. So one important part, like if you want, you can also add one thing as an index, idx. So just up and add this thing here, so this will automatically add it to all the units. And let's just say head idx starts from 0, and whenever we add a new data, we just also increment new idx equals to old idx plus 1. Okay, and when we say data found at head idx percentage d, now run it. See, data found at 4. Search data percentage d, search data percentage d, to know which data is not found. So like that. So search data 7 is found at 4, search data 10 is not found. Fine, right? So this is done. Next thing is what we need to have a logic for delete. For delete, we need to delete a particular data from the linked list, and then we need to print the linked list. So then we are printing it. So let's write the logic for delete. For delete, we will take a particular data, we will search the data and delete it from the linked list. So void delete data. For that, what we need the head and a data that we need want to delete. So first we need the head and the data to be deleted. Let's say delete data. Now let's first understand how this will work. See, if I want to delete fourth node from this linked list, what I need to do, I just need to remove this link and this link, and then I need to link these two. So while traversing, we'll traverse 1, 2, 3, and from 3 to 5. This will automatically be out of the loop. And then we can make this memory as free, right? So this is how we will be doing into the code also. So let's have the address of the previous node. So the address of any node is of type struct node. So we just write prev, and first of all we assign it to null because previous node is null. Then we say while head not equals to, let's say head not equals to null. Okay, fine. Head next not equals to null. We will check if head data equals to delete data. Okay, if the head data is equals to delete data, let's say we will check every data, maybe last node also we can delete. So let's first compare with the null. If head is not equals to null, we check head equals data is equals to delete data or not. Then what we do, if it is equals to delete data, then we say print f deleted percentage d. We just write which data we deleted. We deleted the delete data. Okay, that's it. So we say we deleted it. Now how we delete it, we have to link the previous node next variable with the head's next variable. So head next, fine. So that is done. It is like previous nodes next. See here, so we will be having here this variable next, and this variables next, and this variables next. So this next is pointing there, and this next is pointing there. So what we will do, we'll make sure that this next points towards the next it is pointing to. Understood? The next address which it is storing is a fourth node. We want to overwrite it with the address stored in the fourth node next variable. So that's why we are writing previous nodes next will be the heads next nodes next. It's a bit confusing, but just try to understand. Yeah, you watch the video one more time, then like rewind it. So that's done, right? Then we say break. And also, what we need to do, we need to store previous every time head as previous, and we say head equals to head next. Like that we go one by one, right? Now if suppose this the value which we want to delete is not present, then we can also give the definition like it's not found. For now let it be, we'll give a data that is available and we will delete the node. So after deleting the node, we need to print it. So let's say we copy directly this print, then for delete we just say delete structure node. So we pass head, and we want to delete 6 from the node. So we delete 6. Let's run this. run. Okay, fine. So deleted 6. Okay, fine. We need to have one slash n in between. Let's say here we give printf slash n, create a new line, then we give, see, deleted 6. So previously there was 6, now 6 is not there. Okay, so this is how we do deletion also. So let's see what all we have completed. So we completed search, delete, traverse, and addition. I hope for single linked list this is clear, right? So let's see what's double linked list now. So double linked list. In double linked list, we have one more extra thing, that is the previous. So in first we see only data and next. Now we have a previous, so it is called double linked list. It is like this, pointing forward, also backward. That's why double. Now let's see. Here also we have head. So to create any node, we need to create head. So head will have null for next and null for previous and a data value. So when we create a node out of this structure, we have data, we have previous, we have next. So in this case, previous will be pointing towards null and next will be pointing towards null at the beginning. Now, when we add one more node, then next will be pointing to that node, and previous of this node will automatically point to this node, right? Because that is the previous node. Similarly, the next will be pointing towards null because next is node is not known. If we add another node, the next will be pointing to this node, and previous of it is pointing towards this node here, right? So you understood, right? Next will point forward, previous will point to the backward node. Simple. So for here it is null. So this is double linked list, easy, right? And all the operation remains same. I will show you just. And now here what I need to add, nothing extra, just copy this and add if. That's it. It's double linked list now because it has two directional pointers. Now, when we created a head, what we were doing, asking it to point towards null. Similarly, we will create another priv and ask it to point towards null. And when we create nodes, where is we are creating? Yeah, here. When we are creating add nodes, we are going forward, 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 asking the next to be null. And here we just need to give priv to be, tell me, brief to be the previous node, that is the head. So we'll just pass head. That's it. It's a two directional linked list. Now you can go forward and backward in the linked list. That's it. Now when we reach here, then when we are printing, we'll print forward. Let's create another function print, that we say print node reverse. So what is happening? Why we are saying print node reverse? See here. Currently we also know what is the previous. Start from this node, go to this, and then this. So first we need to reach to the end node, then we will start printing. So go here. We say print node reverse. So until head is null, until head next points towards null, we go there, that's the end node, and we say head equals to, and then we print. Then again another while loop should run, where we say until head if not equals to null, not equals to null, here also not equals to null, we go from head equals to head if, and here we say print. Same thing from here, percentage d head data, percentage d head data. Okay, finally we print null. Let's see. And this is reverse traversing. It's on it. So see, this is forward and this is reverse. Okay, what is missing? We printed 9, then 7, then 5, 4, and 1. Okay, fine. We are missing 1. So why we are missing 1? Let's see. When we are printing head to next is null, we are terminating. Okay, we just say head equals to null. Then it solves our problem. Uh-huh. No, it creates a problem, right? No, okay, not that. Head equals to null. Okay, this one. Now we run. Yeah, see, this is the complete scenario and it printed. Now what is happening? You see, 6 we deleted, but 6 is getting printed here also, because now we also need to delete the previous link. Okay, so previous is linked to next, and we also need one more variable, that is next. So we will say whatever is the next variable means. Okay, now let's look into it. So what's happening? If we want to delete this node, then what we need to do? We need to do the previous also, and this one, sorry, not this, previous to this one also, and we need to link it in this way, and this to this way. So what we need to do? The previous value, what is stored here, previous node value, we need to give to the previous of this node, and the next node value what is stored here, we need to give it to this node, right? Again, let's understand. Previous value here should go here, next value here should go here. In this way, the linking will be complete. So now we do the same thing here. So head next goes to the previous next. So where is head in this scenario? Head is this one. Head is this one. Head next is previous next, and previous value of this should go to the next. Head next means head previous value of this should be stored in heads next previous. So previous value of this should be stored in head next. So we say next nodes previous is head previous, and what we store in the next node, we just store the same thing in the next node, right? So we can just say this is it. Okay, fine. Then now we run it and see what happens. They're saying token missing in 74th. Okay, sorry. See here, now this problem is solved. We have removed that link also. So this delete is clear, right? For the double link list. So what is the difference between single and double link list? I hope it is clear. Single link list, data and next. Double link list, data, next, and previous. That's it. Nothing else. All the operations remain same. I hope you understand. So let's now move to the next topic. Okay. So as I just told you, this is very common question. What is linked list and array, and what is the difference? So this here is a linked list. This is the linked list, and this here is the array, and this is a memory map. So you can consider each block is a memory. So green means free, and pink means occupied. See, a linked list can get memory allocated everywhere. See, one, two, three have consecutive memories. Then fourth one is created here. Then fifth one is created here. Then sixth. Now they are linked, so there is no issue. You can jump from anywhere. So this is the main difference. In linked list, the elements are scattered all around, and only there is a link in between them that creates a chain or a loop in between the elements. So that is how the linked list look in a memory layout. Whereas an array, it will always be in a consecutive manner, in a sequential way. You cannot get one element here and another element here. It's not possible in array. And if you don't have enough space consecutive, suppose you need 11, total 11 element, but all these are blocked, all these are blocked in such a way that you have again 3 free here and again one free here, but still you cannot increase this size from 10 to 11 because you are not getting consecutive 11 in any memory location, and this will give you a error called what, out of stack, like memory out of like overflow will be there, right? Because you don't have memory to allocate. So that is the main difference. So I hope you understand what's the main difference. It's only about the memory layout and organization. Even though you have one single memory space available, you can create a long linked list, but for array you need a sequential and in an ordered fashion only to create an array. Okay, so this, I hope it clears your concept. Thank you.